So this was part 2 of the lesson, and we are now at topics 3 and 4, dealing with center lines. Center line is a new line style for us. We need to use that whenever we involve our compass to draw circles or arcs. So because this is a new line style, we're going to have to understand how to draw it, the pencil to use, and so forth. And then finally, we're going to finish up with the centering a multi-view drawing. Okay, so let's pick it up by going back to the drawing board. Okay, so I have this drawing, a new drawing that I put here, and I want you to create the same thing. I simply started out with a rectangle of any size, and then I projected this upwards, and I drew a circle, and then I drew a box around it. Okay, so it doesn't have to be of any size or exactly like this, just get it as close as you can. And I would pause the recording until you get that done, and then resume. Okay, so I'm gonna pick it up, assuming that you've done that, and we'll move forward from there. All right, so center lines. Center lines have some theory that we have to talk about first. I'm going to go to page 109 in the book, and last week we saw this area for hidden lines, and now we're talking about center lines. So there's a couple of paragraphs that I want you to read, and that's going to be pointing out information, figure 428, which is down at the bottom here. So taking just a quick glance here, you've got a center line that looks like this as you're looking through the hole. Notice there's that little inner cross followed by a gap, and then the line goes out and goes past the edge of the circle. Okay, that's going to happen in all cases where you go past the edge of the circle. So you have the center line that looks like that when you're looking through the hole or the opening, and then you have a center line when you're looking at it from a side view. And if you look carefully, that's kind of just the horizontal piece of this, right? Long, short, long, long, short, long. They officially refer to that as primary center lines and secondary center lines, but that's not something I need you to get too crazy with. We have, what is important is every view that involves a circle must now have center lines, and you need to draw them in there. So that's what we have to learn. And if I just take you to, let's say, this example here on the previous page, you can see the front view, you have half a circle here, so that requires a center line. You've got a hole there and an outer arc, so these center lines have to go out past that. And then in the top view, it shows as the hole going up and down here. In the right side view, the hole goes that way. So they call that the axis direction of the hole. The hole is going through in that direction, so that's where you have only the horizontal one. In the top view, the hole is going through the part in that direction, so that's why you have the center line that way. And on, all right? So there's different shapes will require the same strategy of center lines. All right, so we got this here. I'm going to start by drawing the center line in the front view. Well, let me rephrase it. I'm going to draw the center line in the view that it shows as a hole. Okay? Before we do that, we need to know that when you draw center lines, that's using your 0.7 millimeter pencil. I am wrong on that. 0.5 millimeter pencil. 7 is for hidden lines, forgive me. So 0.5 millimeter pencil. Now center lines are just symbols. Okay? They're not actually physically part of the object. It's a symbol. So because it's a symbol, it's got to be thinner. And this is where your line weights really have to start showing. So your object lines must look darker and heavier than your center line. Now, I'm going to draw it in this top view here, looking down through the hole, and I want you to just watch me here, and then I'll dissect it when I'm done here. So remember, we have that inner cross at the center. And you'll know where the center is because that's where your compass mark is. So it's like going over a pothole when you draw that. You dip down into that little compass hole that you'll feel with your pencil. So you want that nice balanced cross at the beginning, at the middle here. And now we leave a gap and we draw out past the edge of the circle in all directions. And I'll back up and tell you what all of that amount is here. Got a little close on this one on the left, so I'm going to clean that up because I want to do this just right. There we go. All right, so I'm going to draw these rules in on red pencil here, so that in red pen, so that you have this standing out here. So this inner cross of the center mark, that is 1/8 of an inch. Right, so that should sound familiar. 1/8 of an inch is what we draw with our dashes and a hidden line. The space, the gap, after that is 1/16 of an inch. So just like the hidden line, you got 1/8 inch dashes and 1/16 inch gaps. Unlike a hidden line, remember with hidden lines you have that little plus or minus symbol to say it can vary based on the conditions. There is no plus or minus here. That inner cross has to be exactly 1/8 at all times, and the gap exactly 1/16. Then we go out and we draw past the edge of the circle by 1/16 of an inch. And that too is an always, always. Okay, so in all conditions, on all sides of the circle, you are drawing out past it by 1/16 of an inch. So anytime you're looking down into the hole and you're seeing the circle of the compass, your center mark must look like that. Now in the front view, I haven't even drawn the hole yet, and I wanted you to see how I do that. So that's going to show as hidden lines, and that's where I'm thinking 0.7. So I have to line up, right, with my straight edge, I have to line up the outer edge of the hole, the 3 o'clock tangency, right? And I project down lightly, and then I draw my hidden line in my front view from top to bottom. And I repeat that on the left side. I line up my 9 o'clock spot, I project down, and then I draw my hidden line from top all the way to the bottom. Remember, you don't start or finish with a gap or that 16th inch gap. Let me bring this down a little closer. Okay, so you can see where I've constructed my light lines to find exactly where this starts, and then I draw down to where it finishes. And that way I'm assured that my hole in the front view lines up exactly with the hole in the top view. Now I have to draw my center line, which is as if I'm taking this and just transferring it down, right? The axis of the center is up and down. So I'm going to project off my center line in the top view, and I have to draw this 1/16 before I put the dash right in the middle, and then I go down past it by 1/16 below it. Okay, so there is my center line in the front view. Now, just going to emphasize the one rule that's always in action here, is that you're going out past the edges by 1/16, right? So let's write that up, 1/16 inch past edges. Now, here's a little curveball I'm going to throw at you. On the first recording, we learned about scaling, and we spent a good amount of time on 3/4 scale. You do not draw all of these little spacing rules ever at any other scale but full scale or 1-to-1 scale. So even though the drawing around it is being reduced or enlarged, hidden lines should always be 1/8 inch dash with 1/16 space. Center lines should always have that full scale 1/8 inch cross in the middle and a 1/16 inch space, and then draw out past it. Okay, so those things are not, line styles are not scales. That's a good thing, believe me, because drawing a small line, even smaller at a small scale, is not easy. So that's a good, we like that rule. You do not scale line styles. Okay, now, I just got done with all this, and now I have to tell you that there are 2 exceptions to this rule, and they'll make sense once you see it. One is the exception of small, one is the exception of large. So let's talk about the small first. If I have a really small circle, right, and I'm just freehanding a small circle, and then I go to draw the center line, the center mark on here, and I draw an 1/8 inch cross, which almost fills the circle, and then I got to leave a 1/16 inch gap and then draw past it by a 1/16. That's just not going to work. It's not enough room in there. So you'll know that the second it happens, and when that happens, we don't follow any of these rules other than we simply draw. The only rule we follow is the 16th. Is you'll just draw right through the circle, past it a 16th in both directions, and there will not be that little inner cross with a gap. Okay, so that's what your center mark will look like in small circles. And once again, 1/16. So that rule, there is no exception. Let's talk about the exception for large holes. And not necessarily the diameter, but the depth of it. What if this thickness was way deeper? Okay, so I'm going to just quickly sketch an example of that. Okay, let's say once again, this is the front view and the top view. And I have a hole in here. I'll just freehand it for the sake of time. Let's say this is big enough for me to put my center marks in there. And then this hole goes all the way through. And now I have to draw my center line. Okay, so something's got to change here. So what I'm going to do is I need to repeat this pattern that I see here for a rule that I'm going to give you in a second here. So I'm going to have long, short, and then I just repeat that pattern all the way through. And that is because the longer line, right, the longer part of this center line, the rule here is this cannot exceed 1 1/2 inches, the length of that. 1 1/2 max. So if that has to be more than 1 1/2, then you repeat the pattern, and that keeps that rule. It can be less than that, it can't be more than that. All right, so that is the rules for center lines. There's not a whole lot, right? It's a straightforward thing. You just have to learn how to draw the face of the circle and the side view. And, 1/8 inch, 16th inch is the magic numbers, and then this longer one, 1.5 max. You just repeat the pattern. So forevermore now, anything that's round, I'm going to be expecting center lines in all views that represent that circle. Okay, that leads us to our last topic, speaking of centering, is now we have to be able to center our 3 views on the drawing. So I need to fill us in on how that's done. Now, there is a handout, which probably looks kind of scary when you downloaded it and looked and printed out and said, oh my God, what is that? This, historically is not the funnest part of drafting, but it's a necessary part. We have to go through this now before our pencil can even hit the paper. And to give you a sense of understanding, right, if I'm creating a drawing like we did last week, right, let me get the blank sheet of paper. Last week, regardless of what sheet you have, whether it's the this paper or the makeshift title block, if it was this one, I simply said go 1 inch over and 1 inch up, and that becomes the lower left corner of your big ledger L-shaped line. Okay? We can no longer do that. We have to calculate where that point is going to be so that when we lay out the width, the space, and the depth of our front view, the space outside of the views, both horizontally and the space above and below, are equal. So our drawing is balanced. Okay? And that's what this sheet is trying to communicate. All right. So if we look at here, there's the first things we have to know here, and I'm going to circle them, are these red values. All of the red values are always measured with your full scale, right, your 16th scale, because they represent spaces, the space above your object, the space below, the space to the left, the space to the right, and the space in between, which we learned last week forevermore is 1.5 inches. Okay? So you always measure those at full scale. It's only what's in shaded is going to be reduced to 3/4 size. Now that's going to seem kind of crazy, right? And I'll show you what happens. So this is saying the paper's edge, right? This outer box represents your 9 by 12 paper or your 8.5 by 11. So when you're measuring something horizontally, you are literally measuring it in from the outer border of the paper. Why? Because this is 12 inches. That's a nice number to work with. If I measure from border to border, I've got 11 and change, and I don't want to deal with that. I want nice, even numbers. So to make everything work, I just have to know that I measure from the outer edge. All right? So here's what happens. When you measure this thing, you start with the 16th, and you would measure 3 inches. Then you have to flip to the 3/4 size, and you would measure 4 3/16 inches. Then you go back to the full scale inches, and you measure 1.5, and then you go back to 3/4 size, and you measure that. And the same thing up and down, right? Full scale for the space, 3/4 size for the height of your front view, full scale for the 1.5 space, 3/4 size for the depth of your top view. Okay, so that seems kind of crazy, but that's what we do. All right, so what I want to do is kind of interpret what's happening on here. And it's going to seem crazy first time, second time through, but like I said in some other things, it'll just be second nature. All right, so here's what we have to do. I want to show you in a simplistic way how you're centering this. And I just want you to watch me. Don't take notes, just watch me, right? So here's what's going to happen. I'll eventually have my front view, a space, and my side view. And my objective is to get this, which we'll call A, equal to this, which is also A. A and A must be equal. And what do I know? I know that my paper is 12 inches and that my space between it is 1.5. Okay? So I refer to those as constants. You're always going to have 1.5 between. Your paper's always going to be 12. Right? Now I have to say, those of you without the paper, it's 11. Right? So you have 8.5 by 11. So please understand and keep that in mind here. So I'm just going to throw some real simple numbers on here. Let's say that this is 4 inches and that this is 2.5 inches. Okay? So let's just say that that's the measurement of the width of my front view, the depth of my right side view. So in order for me to come up with what A should be, I'm going to take 4 and I'm going to add the space between it, which is 1.5, and then the depth of my right side view, which will be 2.5. So the sum of those three things, 4, 5.5, 6, 7.5, and another half is 8. So the sum of all of that equals 8 inches. Okay? Then I would that would be step 1. Then step 2, I would say 12 minus 8 equals 4. Now that's how much space is totally left over. If I took the distance from here and I shoved it over to the left, I'd have 4 inches left over. I need to divide that in half to get equal spacing. So step 3 would be 4 divided by 2 equals 2. That's my horizontal outside spacing of A. So A equals 2. Right? So if I measured in from the paper's edge 2, and I drew 4, and then 1.5, and then 2.5, I'll have 2 left over. That is basically what we're doing. And then we do the same thing up and down. I add the height of this, plus the 1.5 between, plus the depth of my top, and I have to add all that up and subtract it, not from 12, but from my border to border. I'm going to come back to that. Just trying to reason through what's happening. Now, this is basically what we're doing, but not exactly. It's not realistic. Why? There's 2 things that I have to add to this process. One is I've added all this up as if I'm drawing at 1-to-1 scale, and we're not drawing 1-to-1 scale. Remember, the shaded boxes are what's at 3/4 size. So I have to do something to account for that. Okay? So that's going to be another step in the process here. Then, we're not going to have simple, easy numbers like 4 and 1.5. Life should be so good, right? We're going to have mixed fractions, 4 3/16 plus 1 3/4. All right? So now, if we're not great mathematicians, we've just gotten a headache. All right? So keep the bottle of Tylenol in hand, but I'm going to show you how we'll get through this. Right? Now, in the course material that hopefully you downloaded, you also see this thing, a fraction to decimal and decimal to fraction conversion chart. This also has millimeters. You know, we're not doing that. So really, we're just interested in these, the circles with the numbers. So we're going to involve this. Now, let me interpret what's happening here. Okay, and we'll use the same exact numbers that you have on the handout, which, by the way, is broken down step by step underneath it. But I'm gonna go back through that to make sense of it. Okay, so I'm gonna put this paper up here and a blank sheet below it so that we can see. So here's what we have going on here. Step 1. I'm going to ignore my spacing of 1.5. I'm simply going to add my front view plus my right side view, but I'm not going to keep these as fractions. I'm going to convert them to decimal. Okay? So, it's 4 and 3/16. So I find 3/16 in the little bubble, and I look to the right, and it's actually 4.187. I'm not even going to go 4 decimal places. We're not splitting atoms here. So 4.187, good enough. Plus 1 3/4. So I've got to find 3/4 here. That's 750. Plus 1.750 equals. Right? Now, have a calculator on hand, even though you could probably do that in your head, but we're going to keep stringing this here. Get to my calculator. So we've got 4.187 plus 1.75 equals. So our equals is 5.937. Step 2. Now, I have to account for my scale of my drawing on this. So this is in addition to what I went over a minute ago. So now I have to say 5.937 times 0.750. That's the scale. So we're actually going to get a reduced number, what it's really going to measure on the 3/4 size scale. So now I multiply that 5.937 times 0.75 equals, and here's the reduced number, 4.452. Right? I'm not going to go all the way out to 4 decimal places. Okay? Now, step 3, I want to go back and add my full scale 1.5 inch space. So 4.452 plus 1.5. So I go back and say plus 1.5 equals. And then I get another crazy number, 5.952. So now I'm back to the point where I know what it measures from here to here. Right? I call that my working space. Now, step 4, I say 12 inches minus 5.952 equals. So I'm going to clear this. I'm going to say 12 minus 5.952 equals 6.048. Finally, I need to divide that by 2 to get my equal spacing, A and A. So 6.048 divided by 2, divided by 2 equals 3.024. 3.024. Now, 3 and then 024. So I'm thinking, what's with that? So if I try to find 024 here, that's somewhere between 1/64th and 1/32nd, which is not even on my radar. So ignore the 024. So that is 3. All right, we'll call that dimension A. And that's what we're looking for. A equals 3 inches. So now I would take my full scale measurement and I go from the literal edge of the paper on my drafting paper, right? And I measure in from the left edge of the paper with 0 on there, and I come in 3 inches, and I would do that right on the top of the title block line so I have something to measure to. And I would put a little notch on it. Okay? Then we have to go back through it again for the up and down. Now this says 7 1/4, and that's because I've got between border to border, and I'm even rounding that off. It's a tiny bit more than 7 1/4, but it's a much nicer number. And remember, you're subtracting, you're dividing by 2, so you're going to wind up with a hair difference, and that's okay by me. I'm trying to make it as easy as I can here. So what we need to do for up and down is the same thing. So the height of this is 2 5/8. That's 2.625. And the depth, which is the depth of the up and down here, I'm going to do that in black. So this 1 3/4 is the same up and down. So I've got 2.625 plus 1.75 equals. All right, so here we go again with the calculator. So 2.625 plus 1.75 equals 4.375. That's 1. Step 2, I need to then take 4.375 and multiply that by 0.75 because that's my scale factor. And then I come out with a crazy number, 3.281. Good enough. Step 3, right? I now add my 1.5 inches, 3.281 plus 1.5 plus 1.5 equals. And I've got 4.781. Step 4. It's not going to be 12, it's 7 1/4, right? 7 1/4. 7.25 minus 4.781. Okay? So 7.25 minus 4.781 equals, and that's 2.469. And then the last step is 2.469 divided by 2 equals. 1.234. So now we got to get that back to a fraction so we can lay that out on here. So it's 1, and now I got to find out what 0.234 is here. So 234, here it is right here, which is nasty. 15/64. And I'm going to round that to the nearest measurable thing. I'm close to 1/4, right? That's a really tiny amount. So let's say 1 1/4 is what our up and down measurement's going to be. Now, this is actually a little bit wrong here. This says 1 5/16. That should actually be 1 1/4, which is 4/16. I think that was left over because our older paper we had 7 1/2. Which, when you do the math, that made that a little bit bigger. I never corrected that. So 1 1/4. All right. I know this is, get busy looking at this paper, but remember, you can use a calculator. I just wrote it all out to hopefully make it easy for you. So if you interpret some of this is front plus right side, right? And then that multiply the scale. And then this 1 1/2 is the space between views. And then this is the paper width. Right, is the 12. Okay, so we're going to have to incorporate this now. So finally, wrapping this up, we now have to worry about an assignment. So here is the assignment. Let's read through the assignment first, and then I'll give you some hints and tips. Choose one of the above, right? You have problem 1 or gauge support. 2, draw the front, top, and right side views. So more the same as last week, right? So this is the second time through that. So we have to basically think of these things as 3 rectangles, right? No matter what it is. If you're intimidated by looking at that, we start out with 3 rectangles and worry about the details after. Okay? The drawing scale. So this is new. It's 3/4 inch equals an inch. That's just 3/4 size. 3/4 size. Show all hidden and center lines. So now we have to worry about center lines. So the center lines, because there's things that are round and show all hidden and center lines, but do not draw the dimensions. That's all these numbers. We have to draw to those numbers. We're just not drawing those numbers. The 3 views must be centered on the page. When finished, scan it if you have one of those printers that you can scan, or take a well-lighted cell phone photo. If your room is at all dark, turn your flash on. A couple of you were sending me drawings, and it's like, are you doing this in the dark? All right. So get it well lit. Go outside or go in the kitchen and somewhere to make sure that that's bright, because I can't see your construction lines clearly if the drawing is dark. All right, so take a scan it or a well-lighted cell photo and save as a PDF and email me that file. All right, so let me help you out on a couple of these things here. first thing you have to do is find the overall height, width, and depth. On the gauge support, that's straightforward. We have 5.5. We have 2 9/16. That's a little tough to see. It's a little light, but 2 9/16, and 3 1/16. So we have our three measurements right there. This one, we have to do a little calculating to figure that out. Now the height is right there, 2.5. The depth of this is really disguised as the diameter of this, right? So this is the depth. All right, it's 2 inches all the way around the circle. So from side to side, it's 2 inches. This is the height. It's the width that we have to calculate. The width is disguised a little bit. It's 2.125 plus half of this plus this amount, the radius of 625. So 625 is from the center line out to the outer edge of this. So if we write that down, we've got 2.125 plus 1.000, right? Half of 2 is 1. From here out to here, right? So that's the center, and it's another inch outward, or the radius of that, plus 0.625. So if I add all that up, right, 4, 5, 7, 3.750. So 3 3/4 inches is the width of that. So now I know what my 3 rectangles should be, and I have the information that I need to center it. Okay? So I will do the centering on each one of these to find out what A is for you. And then it's up to you to find out what up and down is going to be. Running out of blank sheets of paper here. Okay, I'm going to do that on the back side of this. Okay, so let me hook this back up. So for the problem 1, the numbers we're looking for is 3.750, which is the width, plus the depth, which is 2. All right, so you've got 5.750. All right, that's step 1. And this is D, W plus D. Then step 2, we have to take 5.750 and multiply it by 0.75. Now back to the calculator. Okay, so we've got 5.750 times 0.75 is 4.312. Forget about the 5. Step 3. I now add, so 4.312 plus 1.5, the space between it, and that comes out to be 4.312 plus 1.5. No way, that's it. 4.312 plus 0.5. Plus 1.5. I'll get this right one this time. Getting tired. 4.312 plus 1.5 equals, yes. Alright. 5.812. Step 4. Now I have my working space, right? The 5.812 represents from here to here. So now I take my 12 and I subtract it from 5.812. So 12 minus 5.812 equals 9.188. Final step, I take 9.188 and I divide that by 2. And I come out with 9.188 divided by 2 equals 4.594. And that is 4, and we have to figure out what 0.594 is. 594 is 9.594 is about here, which is splitting the difference between 9/16 and 5/8. So you could round it down, you could round it up, and that'll be fine. Let's go to 5/8. 4 and 5/8. Now that seems a little big, so I'm going to double check that. I'm getting tired and making mistakes here. So if I lay that out, right, let's check that. So 4 and 5/8. So what's my scale? At full scale, measuring all the way out, I go 4 and 5/8. There's 4 and 5/8. Then the width of my object is 3 and, this looks like it's going to be wrong here. It went wrong somewhere. 3 3/4 at 3/4 size. So 3 3/4. And then 1 1/2 spacing. Yeah, I made a mistake somewhere. And then the side view would be 2 inches at 3 3/4. So obviously I'm way off here. So where did I make a mistake? Back to the drawing board. So 3 3/4 is the width. The depth is 2. Then we multiplied that by 0.75. And we came out with that. Then I added my full scale inch. Oh, that's what I gotta be wrong there. Then I added my full scale 1 1/2. It took me like 4 times to do that. So let's try that again. 4.312 plus 1.5. 5.8 is correct. Then 5.8 is the total working space, and I say 12 minus 5.812. 6. Now it's wrong. I put 9. 6.188. Now that divided by 2 equals 3.094. And it's 3, and then the 0.094 is going to wind up being 3/32. So we could round that down to a 16th or up to an 8th. I'm going to say we'll round it up to an 8th. That's an easier measure. So 3 and 1/8. Okay, so work through that error. So now let's lay that out again. So 3 and an 8th. Sounds a whole lot more like it. From the edge of the paper, full scale. 3 and an 8th. Then 3/4 size, the width of my object is 3 3/4. So I go back to 3 3/4. A whole lot better. Then I go 1 1/2 space between views at full scale. And then back to 2 inches for the depth. That's 2. And then if I did this right, I should have about 3 1/8 left over at full scale. Yep. And I rounded it. So there's my rounding error is about a 1/16 of an inch. I am well fine with that. Okay, so I think I fell victim to fatigue on that. But that's really, it's a straightforward process. Follow the step by step here and try to reason out what you're doing, because you have to do it horizontally, you have to do it vertically. And for those of you without the drafting paper, you're going to have 11 inches wide, or really you're going edge to edge of paper, but up and down, let's take a look at what your actual border is on that makeshift title block, which I have somewhere here, my multiple sheet too. So your up and down is going to be from this border to that border, which, let's measure that, is going to be at full scale 7.5. Okay, so you actually have more vertical space to work with. So 7.5 is what we're going to write down on here. So 11 inches in width, 7.5, right, in up and down border to border. Okay, top of the title block to the bottom of that board. All right, I hope you've followed with me and hung in there. What you need to do is lay out these 3 drawings. Remember, start simple. Get your calculations, get the 3 boxes, right? The ledger line, the 3 boxes, and then work it from there. And then lay out your details, okay? So, good luck, and, I'm rooting for you. So with that said, see you next time.